Hey everyone, welcome to Code Harmony. Today we'll solve this LeetCode design question 3408 design task manager. The question has been asked in Google 6 times in the last 6 months. Let's have a look at the problem statement. These design questions are usually quite important for the interview point of view. So let's see what's given in the problem statement. There is a task management system that allows user to manage their tasks, each associated with a priority. So we have to deal with a task management system where each task is associated with a priority, and the system that we are about to build should be able to handle adding, modifying tasks, executing tasks, and removing tasks. So these operations. So we have to implement a class in short, and this class is going to have a constructor. Constructor is going to initialize the task manager with a list of user task priority triplet. So user task priority triplet is given to us, and the constructor is going to initialize this instance with the given task already given to you. Each element in the input list is in this form. So this is the format of that input: user ID, task ID, and the priority of that task. This is going to add the specific user with the given priority, or this is going to just add the task in the system. After that, there is one function which is add. Add means initially we had constructor which is initializing the system with the already given task. After that, if we have to add any task, we'll just use this function with user ID, task ID, and priority. It is going to add the task in the system. After that, there is another function which is added. Added means added a task, update the priority of the existing task with the new priority. So for any given task, it is going to receive two inputs: task ID and priority. The given task just update the priority to the new priority given to us in this function. So that is another function. So first function is add function, second function is edit function, third function is RMV, remove a particular task with a task ID. So this removes the task identified by the task ID from the system, and it guaranteed that task ID exists in the system. It means we are going to receive a valid input. Against that valid input, we have to remove that particular task against this task ID. So it's another function. And the fourth function and the last function that they are expecting us to implement is that execute top. Execute top executes the task with the highest priority across all users. So the highest priority, we have to keep it in mind that the highest priority, or in terms of magnitude, maybe let's say priority is in the integer form. A task 1 is having priority 2, task 2 is having priority 5, so priority 5 is a higher priority. If there are multiple tasks with the same priority, execute the task with the highest task ID. If let's say task ID is 10, task ID is 12. 10 has a priority of 50, 12 has a priority of 50. Both have the same priority. It means then execute the task with this 12 as a higher task ID value. So that the task ID will become the priority. After executing, the task ID is removed from the system. So it means that when we have to execute a task, we'll just execute the task on the basis of its priority, and if the priority is same, then on the basis of its task ID. And after that, just remove the task ID from the system, remove that task. And how do we ensure, how does the caller is going to ensure that we have executed the task? In that case, return the user ID associated with that executed task. So the task we just executed, return the user ID. And if it is impossible to execute any task, or there is no task, then return -1. So this is our system that we have to create a class named task manager, which is going to implement these 4 functions along with a constructor given to us. Note that user may be assigned multiple tasks. Okay, a user can have multiple tasks. Pretty standard thing. So there are so many constraints as well. The tasks are 10^5 in order. User ID, task ID, priority can go till 10^9, and the new priority is also same. So these are the priority value, these are the task values, and at most 2 into 10^5 number of calls are going to be made to these different functions. So these functions are going to be receiving these many calls. It means that we have to keep the time complexity accordingly. Maybe let's say we have executed a function with a time complexity of n square, which might lead to 10 to the power 10 cases. So that is not going to run and giving us TLE. So we have to make sure that our time complexity is less than n square. The input is generated such that task ID will be valid. In short, that we have to make sure, we don't have to make sure that the valid input is there. Input is already valid. Okay, so this is our function. Create or implement this class, and in this way they are going to test that function. So here task manager is going to give us this input. So the first queries, you can assume that we are going to receive a multiple number of queries, and we have to design a system where we will be maintaining these tasks, and we are going to do whatever is given to us, like whatever function is being called. So first of all, let's try to understand this input. In this input, first query is that we are calling this task manager constructor. It means the constructor is being called, the class is being initialized, and when the class is being initialized, they are calling this list of 3 tasks. Let's say we have this kind of system. In this system, we are also initializing our system with these tasks, and these tasks are 1 is the user ID, 101 is the task ID, and 10 is the priority. User ID, task ID, and priority. This is the triplet that we are going to receive. So this is this I have put in the system. And the second thing is 2, 102, and 20. User ID 2 is having a task 102 with priority 20. I have put it in the system. Third task is 3 with task ID 103 with priority as 15. So now our system is initialized with the task. We are not discussing what is this system, what is this all about. Let's assume that okay, we have some sort of list given to us, and we have just used it straight away. Okay, this is the first query, and after that there is one more query, which is add. Add query is going to get this value. This value is 4, 104, and 5. Okay, for this add query, let's just add it in the system. 4, 104, and 5. Okay, we have added it, and now we have to edit a specific task. Okay, so we have add function, edit function, execute top function, remove function, along with the constructor task manager. So task manager is going to create some kind of system where these operations are going to be running in an efficient manner, not taking so much time, not taking n square time. Let's say as we have to execute. See, adding, editing are simple, but let's have a look on this execute top. What is this execute top? Execute top function is being called. Then we have to extract out a task with the highest priority, and if the priority is clashing, then highest task ID. So there should be a sort of priority queue which is having a priority according to the priority value, and then task ID value. So this is the order in which I have to decide the priority. Check for the priority and check for the task ID. So it means if I just directly maintain a priority queue where I am going to set the priority of every single triplet on the basis of priority value, and if priority value is same on the basis of task ID, then I can have a priority queue. Okay, let's say I have initialized it, I have created this priority queue, and then I'm going to add every single item one by one. Okay, then task manager function will run perfectly fine. Every single item I can add it in the priority queue. Adding in priority queue is log of n time operation, and adding in the priority queue, add function is being called. That is also going to add in the priority queue, also order of n. What about the edit? Edit means edit a specific task. Edit a specific task for a specific priority. See, priority queue, when the priority queue data structure is there, priority queue data structure, it means it is going to give me the topmost priority element in order of 1 time. Apart from that, we can remove the element with the highest priority. We can add the element in the priority queue. All operations are going to take log of n time, but updating a specific value in the priority queue is not a good option, not a good task to perform on priority queue, because when we have to update a specific task, let's say this task, this 102 task, I need to update. To update it directly in the priority queue, I have to iterate over every single item, right? And it is already given that for every single function we are going to have around 10 to the power 5 number of calls. So against 10 to the power 5 number of calls, for every call, if I am doing it in order of n time, in total it is order of n square, which is going to lead to TLE. So to update a task, I can't directly iterate or traverse over the whole priority queue. I would be requiring some kind of faster data structure so that I can access the task in an efficient manner. So for that, what I can do, against the task ID, I need to get some value. So if I just directly create a map, creating a map with a task ID and certain value, and what can be the value? Let's say value is priority for that for now. So when I have to edit it, editing in a hash map is much better, because editing in hash map is like constant operation. Order of 1 time I can get to the same entry and I can update the value. But how I'm going to update it in the priority queue? Updating in the priority queue takes order of n time operation, but we cannot afford that. So what do we do in this case? What we will do is we'll take benefit of some kind of trick, which is usually known as lazy updation. We'll update the value in the priority queue in a lazy format. It means that we will not actually update the value in the priority queue. We will update the value in a separate set. And when I'm going to access elements from the priority queue, I will check whether this entry is a stale entry or a fresh entry. So, okay, in this case, let's see, we are on the edit operation. We have to edit the value of 102 by 8. 102 by 8. It means we'll keep this entry as it is. So this 102 by 8, it is added in the hash table. Hash table is going to have 102 task ID is having a priority 8 now. Earlier it was having some different priority. So what I will do is I will do the lazy updation to my priority queue. It means that I will put another entry, user ID 2 with value 102, now have a priority of 8. So on the basis of this, we'll update our priority queue lazily. And how do we decide that, okay, whether this entry is stale or not? How do we check? When we poll this entry, when we extracted this entry, and we can directly check whether this task ID is having this priority in the map or not. So the map is our source of truth. By checking in the map directly, we will get to know whether the entry is stale or not. So this is the most important part of this problem. Updating this map, updating this priority queue in a lazy fashion. Okay, so editing means I have did this, and removing. And how do I remove it? So as of now, we have concluded that we would be requiring two data structure. One is priority queue and one is map. So just remove it from both the data structure. But how much time does that take? Removing from the map takes order of 1 time if we have to remove from the map. And removing from the priority queue, removing does not happen here, because removing should only be done for the topmost priority element. Otherwise we might have to do the same thing, search over every single item again, and that would also lead to order of n time. So removing is not going to happen. So even in the case of removing, we will remove from the map data structure, and if the entry is removed in the map, it will automatically become stale in the priority queue. So the same concept will be using in the remove as well, but we have the add again. Add function again. In the add function, just add it in the priority queue and the map. Execute top. For execute top, what do we do? For execute top, we'll get the topmost entry from the priority queue, and if that is a stale entry, we'll discard it, otherwise we'll just return it. Okay, now so far we have got some basic understanding that we would be requiring two type of data structure. First one is our priority queue, and the second thing is a map. A map is going to have task ID against priority, and the priority queue is going to have, see, in the priority queue, do we have to add that user ID? Let's say for now we have all the entries, user ID, task ID, and what is the third part? The priority. So we took two data structures, and now using these two data structures, let's try to do the dry run over our sample example. It will make us clear that whether we are able to achieve the solution or not. Pasting. Okay, let's implement over it. We have a priority queue, we have a map as well. So let's say I'm creating a priority queue. So this is the priority queue I have created, and this priority queue is having the priority on the basis of priority value and then task ID. User ID does not matter here. So initially I was having task manager. Let me take another pen. Task manager class. These three entries, 1, 2, 3. These three entries should be added to my priority queue. 1 against 101 against 10, and 2 against 102 against 20, 3 against 102 against 15. So this is the initialization. Our constructor is going to do this, but in the constructor, as we are adding in the priority queue, we should also be adding in the map data structure. So the map data structure will look like this. In the map data structure, the key, we have decided that task ID is going to be my key. Now the task ID is 101, is having priority as 10. So 102 is having a priority of 20, and 103 is going to have a priority of 15. So this is the state. Okay, so constructor code is working fine. Yes, we can do the initialization. After that, we have to add an entry. Add this entry 4, 4104, 5. So task with ID 104 is having a priority of 5. Okay, that is fine. And now we have unique, a new type of request, that is added. Added is going to edit a specific task. It means in this entry, in this request, just a minute, what is this? In this request, we are going to use that lazy updation. So edit means edit this particular task ID. Edit the task ID with task ID 102 with a new priority, that is 8. So 102 with the priority 8. So how do we do it? I can directly add it in the map. In the map, I can add the updated value. But what about the priority queue? In the priority queue, the previous entry will become a stale entry. New entry will be added. What is that new entry? New entry is 102 and 8. But what about the user ID? So we don't have the user ID. So why we are keeping track of the user IDs? Instead, let's remove all the user IDs. So they are useless for us. If I just remove all the user ID, that is fine. But I still remember that in execute top we have to return the user ID. So user ID kahin to use hogi. It means that I have to keep it somewhere. So where I can keep it? I can keep it in the map. In the map against the task ID, what I can do is I can keep the user ID and the priority. And instead of this priority queue, I can remove this user ID so that I can update the new entry in the priority queue comfortably. So here I am adding the new entry 102,8, 102,8, and the 102,8, this is here. And here I also need to map the user ID. So user ID is 1, user ID is 3, user ID is 4, and user ID is 2, 1, 2, 3, 4. So this looks better. This is how we generally build our approach when we try to run our given example. Okay, this query is also working. Execute top. Execute top. This is the main function. In the execute top function, we are going to pick the topmost prioritized element. That is according to priority. According to priority, this is the topmost priority element, which is 102,20. Okay, I will get the top value. Top value is coming out as 102,20. But I will check in the map that whether this task ID is having this priority. Actually, this task ID 102 is having a priority of 8 in reality, in updated one. So it means this entry is a stale entry. It means get another one. This was a stale entry, get another one. Another one is 103,15. 103,15. 103,15. I will check in the table, in the map table, whether this 103 task ID is going to have a priority of 15. Yes, this is a valid entry. So we can choose this entry, and it means then this is going to be giving us the answer. And what is the answer? Answer is the user ID. So 103 I have. According to 103, go to this row and take this entry, and among this entry just get the user ID value, which is 3. So 3 I can return. So far none of the request is going to return something. First request is going to return 3, and next is execute top is going to have a empty input, and the return type is 3. Now remove this entry, remove the 101. Okay, removing 101 mean just remove this entry from the database. HashTable will keep the stale entries in the priority queue as it is. Okay, now add another entry. Another entry is 5,105,15, but user ID we am not putting in the priority queue. So 105,15, and in this case 105. The priority is 15, and what is the user ID? User ID is 5. Priority is 15, user ID is 5. So okay, I have inserted it. Now the next part is execute top. The last query is execute top. In this case, what value I should execute? These two entries are already removed. So the topmost priority element is 105,15. So I will be getting 105,15, and when I go to the relevant row, I'm able to see that user ID is 5. So print the user ID as 5. So this is my output table, and here we have come to a conclusion that our final state will look like this. We have to maintain a priority queue, and this priority queue is going to take task ID and priority, and we have to take a map as well. Map is going to take a task ID, map to what? Map to priority, what is the second part? User ID. So this is our final approach, and here we have designed something. This is this data structure, and this data structure is our task management system. So in this task management system, we can now think of the time complexity of certain operations. So first one is initialization. In the initialization, we are just adding the entries. Okay, adding the entries in the priority queue, order of log and time, adding entries in the map, order of n time. Then add query, log n time operation, edit. What is the edit? Time complexity of edit. Edit means, let me write down here. Constructor, add, and now second part is edit, then remove, then execute, EXEC. So constructor is going to add every single item in the priority queue, and adding items in the priority queue is log of n time. So whatever item I'm going to get as a part of constructor, the task, number of tasks, will just take a log n time. Let's ignore this constructor, it's a one-time operation. So these are the queries. So adding operation is also going to take around log n time per query. Edit operation, and why add log of n time? Adding in the map, constant time, adding the priority queue, logarithmic time. What is edit? Edit means adding in the priority queue and updating in the map. So that is also log n time. Removing means removing from the map and not doing anything with the priority queue. So that is order of one time. And what about the execution? Execution means getting the top element from the priority queue. We have to poll the entry from the priority queue, and polling entry from the priority queue is log of n time operation. So this is the time complexity. But in this case, we can see that okay, we might have to poll stale entries as well. So even if we are polling the stale entries on the overall basis, it will only be log of n. We usually call it amortized log n time complexity. On average, considering the cases from the previous entries, it is almost order of log n. So this is the per query time complexity, and if we are getting n number of queries, so it is like this, n into log n. So that was about the approach, and now let's have a look on the code. So here in the code, first of all, I have initialized my priority queue and the map. I have initialized the priority queue and map like this: task ID and the priority, and task ID in the user ID and priority. I kept the user ID in the initially at the index 0. So initialize both the priority queue and map. And when we are initializing the priority queue, you should be able to understand this code part. Like, see, let's ignore this if condition. B1 minus A1. It means we have in the priority queue on the first index we have priority. A have some priority, B have some priority. If B priority minus A priority is a positive value, it means B has more priority. Keep the B to the front, swap them. And that's why we are keeping it in an order that okay, we are getting positive value, we are doing the swapping like this. If these are same, then we'll just pick on the basis of task ID. So this is just the initialization, and after that I have to add it. When I have to add a task, I will add it in the priority queue as well as in the map. When I have to edit it, when I'm editing it, I'm just editing it in the hash table. In the map. And what about the priority queue? In the priority queue, just keep the stale entry as it is and just put the new entry in the map. For the removal, just remove it from the map. It is lazy removal. Stale entry against this will be removed in the execute top function. As far as we are able to keep getting the stale entry means when the entry that came out as a top priority element. When the top priority task is not present in the map, it means it is already removed. If it is present in the map but the priority is different, it means it is a stale entry. So this is the logic. So that's all about the code and implementation part. So that was the most important thing to decide over the data structure, that this data structure we are going to use. And do let me know in case you have any doubt, and thanks for watching guys. Bye bye. Let me submit this as well. It is submitted successfully. I recently submitted, and this is the code that I wrote. I'm also going to attach the code in the description below for your reference.